paper 43. Let's take a look at question number 1. A person's eye color may be categorized as brown, blue, or other. The scientists claim that these eye color are uniformly distributed and hence equally likely to occur in the populations. A survey of 120 people, these populations found that 38 people had brown eyes, 52 people had blue eyes, and 30 people had eyes which were neither brown nor. Use the data to carry out a goodness of fit test and 5% significant level to the test the scientists claim. Okay. They uniformly distributed. So this is a uniformly distributed means that the probability is equally same. So we start from the null hypothesis, saying that according to the scientists' claim is that the uniform distribution is a goodness of fit. Uniform is a goodness of fit. Okay, the sentence is too long. Fit to the data. Okay, so this is your null hypothesis, and your alternative hypothesis will be the opposite of it. That means we just write that the uniform distributions is not fit. No, do not say goodness of fit. We say just good fit. A good fit to the data. It's not a good fit. The data. Okay, so this will be more proper. Okay, now we need to build the table first. Because we need to find the expected frequency. So we have the color. Have a blue. We have a brown, blue, and other. So the observed frequency is given in the question as the brown has 38, the blue has 52, and the other have 30. So the expected frequency is 120. So if it's a uniform distribution, that means you just take the 120 divide by 3, you get a 40 and 40. The frequency to be all the same. Okay, so this is the table that we need to build. Okay, so now what is our significant level? Significant level is 5%. Okay, what is our degree of freedom? The degree of freedom is 3 minus 1. 3 columns over here, so you have a 2. So your critical value, the I square of the degree of freedom 2, 0.95. So from the formula table, you can get this one as a 5.991. Okay. Then we go and find the test statistics. The test statistic is just a chi-square. The formula for chi-square is a sum of the OI minus the EI square divided by EI. So you just need to take 38 minus 40 divided by 38 minus 40 square and then divided by 4. So over here, if you press a calculator one by one, get this. So I just show the result. But you should know that this one, it means 38 minus a 40 square divided by 50. You should know that this one means 52 minus a 40 square divided by 50. And the last one over here, you should know is 30 minus a square divided. So I didn't write this one out because I just used the formula over here to represent them. Then I just show the value that I press one by one. Okay, each and every terms that we have 3 of them. So these are the values. And after that, total them up, you will get this one as the 6 point. This is your test statistics. So you compare the test statistics with the critical value is bigger. You can see that the test statistic is bigger than the critical value. That means you're supposed to reject H now. Okay, so conclusion. There is sufficient evidence to suggest that uniform distributions is not a good fit to the data. Distribution is not fit to the data. Done. So this will be the answer for the question number 1. Okay, so now we move on to the question number 2. Increase the yield of tomato plants. The farmer selects 40 tomato plants at a random and give them new fertilizer. The crop mass x kg of each of these 40 plants is recorded. The farmer selects the further 60 tomato plants at random and give them the standard fertilizer. Crop mass y kg of each of these 60 plants is recorded. Okay, so these are the results that they give you. Then find a 90% confidence interval for this difference in crop mass associated with each type of fertilizer. You need to find confidence interval. So what you need to do, first of all, we need to find the bar x. That means you just take the 168 divided by the 40. The bar y, it will take divided by 60. So if you press the calculator, get this one as 3.8. Then we need to find the unbiased estimations of the population variance of x. That will be 1 over 39, 720 minus the 1x squared divided by t. Press the calculator, then you can get the answer. I write them in my significant figure, 36923. Then sy squared, 1 over 59. 900 minus the 8 square divided by 60. Again, press the calculator, give the answer in 5 decimal places. 5 significant figure or 5 decimal places, that is fine. So you get 0.56949. Okay, so you have 2 set of data. We need to combine them. Okay, so we combine them. We have a combined variance. S square is equals to 0.36923 divided by 40 plus the 0.56949 divided by 60. Again, use a calculator. You will get this as a 0.0 18702. 7, no, not 02, 22. Okay, so this is the combined variance. Okay, then they mentioned 90% of the confidence interval. Since confidence interval is tail, so we are looking for the critical value. The formula booklet. This is D distributions, 0.9. So just look from the formula booklet and get this one as a 1.645. Okay, so now we are ready. The 90% confidence interval, the differences in mean. Difference in mean. It will be equal to the bar x minus the bar y plus minus of x 0.95 square root of s square. So it will be 0.2 minus a 3.8 plus minus of 1.645 square root of 0.072. So the rest, just press the calculator. The smaller value you put it here, the bigger value you put it, and this is the interval. Done. This will be the answer for the question number 2. Move on, we have question number 3. Most random variable x has a PDF given as the following. These five functions over here. They say that the k is the constant and they wanted to show that the k is 125. So we know that integrate from the 0 until 8, get a 1. So that means if you integrate 0 to 1, the x plus integrate 1 until 8 over a 8 minus x dx, it will be equal to 1. So we can integrate them one by one. You have a kx squared over 2, 0 to 1, plus the k of 8x squared divided by negative 2. This one is 1 until 8 equal to 1. So you have a k over 2 plus the plus the 49 of a equal to 1. So total you get 50 over 2 at 25k equal to 1. Therefore your k is shown. Done for the part A. Now we move on to the part B. We want to find the median of the value of x. So over here, to find the median value of x, we integrate 0 to 1 k x dx and get this one as the x squared over 50. 0 to 1, you will get this as 1 over 50. It's still less than half. Okay, because median means that the total is the area is a 1. The total area is 1. So 1 is 1 over 50 is still less than a half. Sorry, median means that the area is a half. Okay, median means that the probability less than m is a half. Okay, so this one less than half means your median will be somewhere in between 1 to 8. It will be somewhere here. It will be somewhere here. Okay, so we need to integrate 0 to 1, 1 over 25x dx plus the 1 until m, k, x minus dx is equal to half. So we already know that this is a half, this is a 1 over 50. And this one we can integrate them. So you get this one as a negative t, 1 until m equal to half. Get this one as 50 plus the 59 or 50 minus 8 minus the m squared equal to half. Okay, so we will be having this is a 1 minus the 8 minus the m squared over 50 equal to half. Is 8 minus m over 50 is equal to half, and 8 minus m is equal to 25, which means that your 8 minus m is equal to plus minus 5, and your m is equals to the 13, m is equals to the 3. The m equal to 13 is already more than the interval, so we reject this. Therefore, your m is a 3. That's all. M is a 3. So this is the answer for the number 3b. Move on. We have a 3c. The variable and the variable y, which is defined by y is a cube x. We want to find the PDF of y. Find the PDF, we need to find the PDF of the x. So we need to find the f1, means integrate from 0 until x, a, x, x. So this will give you, this one will give you x squared over 50, x squared over 50. That is your f1. Then f2, to be integrate, that means we will need to f1. This one is the interval from 0, 1. This one is from 1 until 8. Okay. So if you put 1 inside, then plus the integrate 1 until x of the a multiplied by x minus x. So it will be 1 over 50 plus the x minus x squared divided by negative 50, 1 to x. Get this 9 over 50 minus the x squared over. Simplify it. Get this one as the 50 minus the 8 minus the x squared. Okay, so that means my fx will be equal to the CDF of x will be this. Can write it like this. one is for x less than 0. This one for the x 0 to 1. This is for the x between 0 to a. This is for the x greater than a. Okay. Now we want to find the y. dy means the by less than equal to y will be the cube root of x less than y. That means it's the x less than I cube. So means it's fy cube. So that means I am ready. I need to change all the x over here become y cube. Change all the x become y cube. So you will get this as a 0 y cube. That means y power 6 over 8. You need more space. Y over y power 6 over 50. And 1 minus the 8 minus the y cube square over d. And this is the 1. This one is the y cube less than 0. The y cube between 0 to 1. And between 0 to 8. 1 to 8. And this y cube will be greater than 8. Okay, that is your dy. But this is a CDF of the y. We want PDF of the y, which means that I need more space over here. So to find the PDF, I just need to differentiate the CF. Let's differentiate them one by one. You will get the 3 over 25 y. Then differentiate this, you will get this. Okay, then differentiate the second terms. Differentiate these expressions. Then you will get 6y squared 8 minus a y cube over the b. You can have something like that. Then this one is a 0 for otherwise. This one is for 0, 1. This one 1. Okay. However, 6b we still can simplify further. Make it become 3 over 30. Okay, so this is my answer. Oh, sorry. I make a mistake here. I forgot to settle all this. And make it become y. Y over here is 0 to 1. One is but this one is a 1 y from 1 to 2. Okay, so this is the answer. Okay, so done. A bit long, the process, but this is the answer. So now we move on to the questions number 4. We have a researcher claims that older people take a longer to react a sudden loud noise than younger people. Investigate this, the researcher randomly selects 6 people over 50 years and 8 people under 25 years. Records their reactions times in milliseconds. A sudden loud noise. Reaction times this one is under 50. Okay. we take a look at the questions over here. We want to carry out a Wilcoxon rank sum test at 5% significant level, test the researcher's claim. So to save time, I built the table over here in this way for you all, particularly. And before that, we can write down our null hypothesis and the alternative hypothesis. The null hypothesis is just that we just say that the population median M is over here. We say that according to the researcher's claim, say that older people take a longer time to react to a sudden loud noise than the younger. That means the median the people is equal to the median young people. Okay, then versus the population median, you follow the researcher's claim, means the median for the older people will be greater than the median of the young people. Okay. So we need to calculate the ranking here. So we need to make sure that it's in the ascending order. Okay. This one also make sure it's ascending order. So both of them are in ascending order. So we can just do the ranking. We start from the smallest value. I give rank number 1, rank number 2, 3, 4, 5, 6, 7, 8, 9, 10, number 11, 12, and then 4. So we total the rank over here, you will get this one as the, you will get this as the 45. Now, by the way, the M over here is referring as a smaller, this one is the M. So we have 1, 2, 3, 4, 5, 6, M is a 6. And the N is a 8. Younger people data have 8. Okay. So M is smaller. Okay, so we need to find the R6. This is the R6. And we need to calculate the 6 plus 8 minus 1 and plus 1 minus the R6. Formula will be Rm, and this one it will M plus N plus 1 minus the Rm. You want to check who is bigger and who is smaller. So this is the value, and calculate this, and then you can get this one as a 30. Your test statistics is actually the minimum between 60 and 30. So obviously is 30. Then we want to find a critical value. To find a critical value, we need the alpha. Alpha is 0.05. So over here, the critical value of the tabular value, maybe we write critical value or tabular value is fine. So I write C critical value is equals to the 31 from the table. The formula MM19. And you compare your test statistics, you compare to the critical value is less than, your test statistics is less than the critical value. This is the Wilcox test, so the sign will be opposite than the usual one. Less than, then it's supposed to be equation up. So this one is opposite. Sign is opposite compared to the t-test chi-square test. So reject H now. Conclusion is the researcher claim is correct. There is sufficient evidence to support the researcher's claim. That's all. This is the answer to question number 4. Now we move on. Question number 5. Have a doctor is investigating the connections of blood glucose in the patient at risk of developing type 2 blood glucose is measured in units. Doctor claims that a particular intervention uses the concentrations by more than K unit. So this is an important statement over here. Average. A group of 8 at-risk patients is selected at random and each patient follows the interventions for 6 months. The blood glucose concentrations before and after the interventions are given in the following table. Okay, so use a t-test at 5% significant level to find the range of the value K, which the result test is to reject the null hypothesis. Okay. So we need to write down the null. The null hypothesis say that the difference, because the doctor claims that there is a difference because the intervention after that will reduce the concentrations. That means the mu A is equal to mu B is equal to, this one is that the mu or is actually greater. Oh, sorry. They say by K unit. By K unit, not just reduce by K unit. So over here, that means this minus this. Okay. This give you use more than K unit. That is a meaning. Okay. So I have to be careful. So before and after, we need to find the difference. The difference is actually the B minus the A. So the B minus A, get this one 19, 17, 8, 16, 9, 3, 6, 9. So we need to find the sum. The total over here is 103. So I have the sum of the D. I have the sum of the D square is equals to 641. Direct plus from calculator will do. Okay. I need to find the unbiased estimations of the population's variance of D. D1 over the 7. 641 minus a 1, 3 square divided by 8. Press a calculator, you get 44.982. Okay. These are the things that we need. Hypothesis test. Then your alpha given is 5%. So your critical value, this is a small sample size, so we will use S. We use t-test, but t-test we need to find degree of freedom. The degree of freedom have how many data? You have total 8 data. So 8 minus 1, 7. So the critical value will be D, degree of freedom 7, and your confidence level is stable. We'll get this one as 1.895. And your test statistics will be the D is equals to the D minus the K divided by square root of S squared divided by 8. Okay, so this F. You replace the value, the bar D, by the form of the never mind. Bar D is right over here. Bar D is 103 divided by 8. So 103 divided by 8 is 12.875. 12.875. Now you get 12.875 minus a K divided by the square root of S squared, or 4.82 divided by. So this is the test statistics. To reject H now, that means your test statistics must be greater than the critical value, which means that the 12.875 minus a K, the square root of 982 by 8, it must be greater than 1.5. Okay. So over here, if you press the calculator, then you can see that 12.875 minus K, it will be greater than 1.5 square root of then again, simplify further, you can see that your K will be less than 8.38. Okay? K less than 3.38. So over here, we need to understand that the K, this one, it could still is equal to 0. It could go until here, which is the VA equal to mu A equal to mu. It means there's no difference. Okay, there's no difference over here. So over here, we need to mention that the K is greater or equal to 0. It's possible that minus a mu A 0, then it will give you mu. So is it possible to get the mu less than the mu A? That means the mu B minus the mu A negative. Is it possible to get something like that? It's not possible. You test because you are using the intervention. So by right, first you can get is that there's no difference. Okay. First you can get is no after the intervention there's no difference. Okay. Usually we were not able to get after the intervention, it will get worse. Okay. So this will answer. So the K is possible to get 0 till 8.38. That is the answer. Okay. So shown. Then we go for part B. State the assumption that is necessary for the part A to be valid. For the part A to be valid, because we are using t-test. So for using t-test, there's one assumption we need to make is that it is a normal distribution. Okay? But did they mention, question mentioned normal distribution? The question didn't mention anything about. So we try to use t-test because the question asks you to use t. So in order to use t-test, assume. So the assumption is the under the populations of differences Relations, differences in mean. Relations or differences in mean. Are normally distributed. Okay, done. So this will be the answer for the question number 5B. Move on. We have a question number 6. Select two balls at random without replacement. Number of red balls selected by Kiran denoted by X, and the number of different colors presented in Kiran's selection is denoted by Y. So we want to find the BGF for the X and the BGF for the Y. So over here, X equals to the number red balls. So the X no red ball, one red ball, red ball. Okay, so we have a random variable 0, 1, 0, 1, and 2. Okay, so for X equal to 0, since you are selecting them without replacement, no red balls means the two balls are all 2, C2 divided by 10 C2. So you will get this one 1 over 15. Then X equal 1, that means it's a 7C1 multiplied by 3C1 divided by 10C2. Then you will get this as a 7, and the X equals to 2. That will be 7C2 divided by 10C2. Then you will get this 7 in as well. Okay. So therefore, for BGF X 15 plus the 7 over 15t plus the 7 over 15t squared. So this is the answer for number 6A. Or you have for the Y, haven't finished yet. So the Y over here is representing the number of different colors. Number of different colors. So this one is a bit controversial. Okay. You can see that this one needs some explanations over here. If you have one red ball and one blue ball, how many different colors you have? Some will say that different color. Okay. Okay. Then if in that case, what about this? If you have two red or two blue, we say that this one is a no different color. Okay. So actually it's possible. Actually it's possible. It depends on how the bread, the situations over here. So when we say number of different colors, you can say that one red, one blue. You can consider it as two different colors. And then two red or two blue, you can say that no different colors. There's no difference of color. Of course, we do have different opinion. Some will say that if this is a two different color, then by right, this one should be considered as one different color. Some people will think that this one should consider as you have one color are different. Okay. So if you say that one color are different, why not we say that this is one color are different over here? Because you can see that if you have one red and there's one color here is different than the red, and say that this one is one different color. And why not we just call this one zero different color? So it's also possible. So that means actually we have three possibility. Okay, so we have a possibility that the y can be 0 and 1, or the y can be equal 0 to 0 and 2, or the y can be 1 and 2. So you may consider that this one is no different color, then this one different color. This one is no different color and two different color. This one can consider as one different color. This one is two different color. So actually, you can see that in the mark scheme, they allow any of the three cases over here. In the mark scheme, they actually allow any of the three cases over here. So it depends on how you want it. Okay. So actually, any one of them over here is fine. Okay, they will accept it. Accept it. You can see that they accept that as an answer. Okay. So over here, since we have option, you can choose the y is equals to the 0, 1, or the y equal to 0, 2, or the y equal to 1, 2. Okay, so either one is okay, it's fine, no problem. So I will choose the one that is the main answer given in the mark scheme. The main answer given in the mark scheme is they treated the one different colors and two different colors. Okay, so we'll follow that. But you can see the remark in the mark scheme, they actually allow these two, we consider these two are the special case. These two are special case. Okay, so this special case and this special case both can be accepted. Okay, so we follow the main one. Okay, so the main one over here, our y is actually 0, 1 and 2. One different color and two different color. Okay, so in that case, you need to find the py equal to 1. Py equal to 1 means you have either two of them are red or two of them are blue. So if you add them up, get this as a 8, then py equal to 2. That means you have one of them is red, of them is blue. That will be 7 over. So therefore, your BGF for the y is 8 over 15d plus the 7 over 15 squared. Okay, done. So for the other cases, for those who are using y equals to the 0, 1, y is equal, may refer to the mark scheme, special remark over there. Okay. So now move on. Part B, the random variable z is the sum of the number of red balls and the number of colors and in selections. Kieran claims that the probability generating functions PGF of stack is in why Kieran's is incorrect. So this one is only one mark. We do not need to explain so detailed. That means the only reason that they, because over here we know that the z is equal to y. The g z supposed to be the g x plus y t. So according to Kieran's, it's supposed to be presented in this way. Okay, according to Kieran's, because Kieran claimed that it's like that. So since they want to mention that it's incorrect, okay, we want to explain why it's incorrect. And the only possibility that they are incorrect is they are not independent. Okay, so remember, this is true only when x and y are independent. So if they are not true, that means X and Y are not independent. Okay. So over here, we do not need to explain so much. Okay. So you just need to say that if the GD is not equals to this times this, that means the X and Y are not independent. That's all. Okay, so this is the answer for the number 6B. Now we move on to the 6C. Find the PGF for Z, expressing your answer as the polynomial in D. So, however, they still want us to find the Z. Okay, but from part B, we know that they are not independent. So we actually cannot use the GX multiplied by GY to find the GZ. Okay, so what you need to do now is to build the table. See the relationship of the X and Y carefully. So for X, it has a possibility of red ball, one red ball and red ball. And for the Y, we follow the main the main answer. The main answer is that they let the Y equal 1 and 2. Okay. The random variable for Y is 1. Have 1, we have 2. So if you add them up, you may get one the you get the so-called X plus Y. Z is equal to 1. Okay, this one it will give you 3. So actually over here you can see that the 0 for the X and Y is a 0, 1, 2. So this one is 1 and 2. So you can actually have a relationship. If it's add together, get 1, you get a 2. If you add this together, you get a 2 and a 3. You add this together, get a 3 and a 4. Okay. So we need to consider the situations that this one is the and the 2, 2. Okay, we need to consider all these situations. So because at the end you can get the random variable is 1, 3, and 4. 1, 2, 3, and 4. So we need to find the probability. Okay. So to find the BZ, that means you need to calculate no red ball. No red ball means the 3 of them is green ball. So this one is representing the BX 0. And then multiply by the B Y equal to 1. For the Y equal to 1 means you have one color. Okay. One different color, that means both of them are blue. Both of them are blue. Okay, because this one is representing blue. Okay, so for this case, this is the probability. You can only get this one as the 1 over 50. Okay. So over here for the BZ equals to 3. BZ equals to 4. How about, is it possible to get BZ equal to 2? Possible to get BZ equal to 2. BZ equal to 2 means you have 1 plus 1. 1 plus 1. That means the red ball, you have 1 and you have 1 color. But if the red is equal to 1, that means another one must be blue. If you have the red is a 1, another is blue, then it cannot be one different color. It must be two different colors. So this is not possible, okay? Bz equal to 2 is not possible. Bz equal to 2 is not. So this one we do need to show. Okay. So what about Bz equal to 3? Bz equal to 3, it will be 1 plus 2 or 2 plus 1. Okay. So what does it mean? The 1 over here means you have a red is equal to 1. This one means the red is equal to 2. Okay. So if red is equal to 1, is it possible to get two different color? Possible. Okay, possible. So over here, if the z red equal to 1, that means it will be the 7c1 multiplied by 3c1 divided by 10c1, 10c2. That will be the case. So this case will give you this case will give you 21 over 4. So that will be 7 over 15. Okay. And then just now I mentioned 1, 2, right? Now it's 2, 1 over here. Okay. So 2, 1. This one we calculate another one. So over here, this one is the 7 over 15. What about the 2, 1? For the bz equal to 3, you still have another possibility, which is the z equal to the 2 plus 1. That means the 2 over here is representing the red is equal to 2. This one, it means that you have a one different color. So if we consider that case when the two balls are same color and they are both red, then the chances will be 7c2 divided by 10c2. 7c2 divided by 10c2. You will get this one as the 7 over. Okay, so that is the case. Then this one it will be 7 over 15. What about 2, 2? Bz equal to 4 is equals to the Bz plus 2. Okay, 2 plus 2. So this one means you have the red is equal to 2, but you have a two different color. So this case is not possible. It's not possible. Okay, this case is not possible because it's not going to happen. How to have two balls same color and you can say that they have two different colors? That will be not possible. So this one, that's why the mark scheme didn't put down this probability. It just give the table like that. Okay, so after we have done this, now we are ready to find the BGF for the Z. That will be 1 over 15 t plus the 7 over 15 t cube plus the 7 over 15 t cube. Okay, so over here we will join together, make it become 14 or 15 t cube. Okay, so this will be the BGF for the Z. Now we move on. For the question D, we want to find the mean, the G, the EZ. So we just need to differentiate the BGF for the Z. It will be 1 over 15 plus the this one differentiate cube. 14 times 3, 42 over 15 t squared. Then the expected value, it will be the g prime 1. It will be 1 over 15 plus 42 over 15. That will give you 43. 15. Done. This will be the answer for the question number 6D. And this will be the last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.